The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, well, we've got a short week this week. We meet today and tomorrow, and then of course there's no class on Friday. But today we're going to be covering sections 5.4 and 5.5. Tomorrow we'll cover, 5.6 and 5.7. Monday, 5.8 review, test on Tuesday. Okay, so if any of you have any questions about your test, please email me and I'll go over questions with you if you want. I'm not going to spend class time doing that, but I will say that I got through correcting all of them, looked at people's work and evaluated it and everything. So that's all good to go. Also, I have one question from a student who's actually working ahead. I'm going to go ahead and do this one question. This is from section 5.4, number 18. So this is going to be part of tonight's assignment. And this is what the question says. It says, evaluate the expression, and the expression is 1/4 b squared minus 1/16 b. And there's a part A that says b is 16, and we'll take a look at that. So we have this expression, we're told that the variable equals 16. So what we do is we put 16 in the place of b everywhere it appears in the expression. So we would have 1/4 times 16 squared minus 1/16 times 16. Well, let's see here. 16 squared is 256. So this is 1/4 times 256 minus the 16 and the 16 reduced, so minus 1. 256 divided by 4 is 64, and 64 minus 1 is 63. So the answer to part A would be 63. Part B says B is negative 16. So now, let's see here, we'll need some more room here. We'll erase this, and we'll use that area. So for part B, we'd have 1/4 times negative 16 squared minus 1/16 over negative 16. Well, negative 16 times negative 16. Negative times negative is still positive, so we get 256 divided by 4 minus, negative 1. So plus 1. So we end up with 256 divided by 4, which is 64, plus 1 is 65. Anyway, so that's for that one student. And now we're going to go ahead and officially start section 5.4. Okay. So we're going to talk about polynomials. Okay. A polynomial is an algebraic expression. So it's an expression that isn't just numbers. It has at least one variable involved. So for instance, x squared, that is considered a polynomial. 3x plus 4, that is considered a polynomial. 7x squared minus 2y plus 18z, that is considered a polynomial. Now, there are different kinds of polynomials depending on how many terms there are in the polynomial. What is a term? A term is separated by addition or subtraction. So for instance, x squared has one term. 3x plus 4 has 2 terms. 7x squared minus 2y plus 18z has 3 terms. Do you know what a monocle is? The only example I can think of is an old TV show called Hogan's Heroes, and there was a guy named who was Commandant Klink, and he wore a monocle. It's just a single lens. Mono means one. So if we have one term, it is a monomial, as in one term. A bicycle has two wheels. Bi means two. So two terms would be a binomial. A tricycle has three wheels, so three terms. So let's see here. So a trinomial, three terms would be a trinomial, okay? Monomial, binomial, trinomial, one term, two terms, three terms. Now, beyond that, four terms or more, we don't get into quadrinomials and quintrinomials. We don't tend to call them that. We just call them all polynomials. Poly means many, okay? Now, the math community does this. It doesn't work out well with the English community, but a monomial only has one term. Polynomials means many, but yet all of these, including monomials, are grouped together and referred to as polynomials, though technically I would argue, is a monomial really a polynomial? But the math community does that. So these are all called polynomials. All right, any questions about that before we go on? Okay, let's see here. Let's get rid of that. And let's go back to, let's see, 4x plus 2. This is a polynomial. Specifically, it is a binomial, so it has two terms. The first term is 4x. The second term is 2. The first term, because it contains a variable, we say it is a variable term. The second term only contains a number, so it is called a constant term. All right. Now, let's focus on the first term. This is a variable term because it contains a variable. The number in front, 4, is called the coefficient of the variable, or you could say it's the coefficient of x if you wanted to be specific about it. All right. Any questions about that? Let's say we've got 7x squared minus 2x plus 4. The first term is 7x squared. Its coefficient is 7. The second term is negative 2x. Its coefficient is negative 2. Now, wait a minute. Why is the second term negative 2x instead of 2x? Well, let's back up a little bit. I said that terms were separated by addition or subtraction signs. Technically, terms are separated by addition signs. So what does that mean? Well, that means that if we looked at this and we wrote it in terms of addition, we'd have 7x squared plus negative 2x plus 4. So in terms of addition, this second term would be negative 2x, and its coefficient would be negative 2. Okay, so we don't have to rewrite this like that, but if we're talking about the second term, it's negative 2x, and its coefficient is negative 2. All right, any questions about that? Okay, let's go back and take another look at this. The first term is 7x squared. Its coefficient is 7. But what about the degree of the term? The degree of a term is the sum of all the exponents on all the variables within that term. So the first term is of degree 2 because there's a 2 exponent on the x. Okay. The second term is of degree 1. Recall, and this is another one of those things where in a previous math class, supposedly you learned this, hopefully you did. If there's no exponent on the variable, it's an implied 1. Okay? Now this next one's a little tricky. The third term, term is of degree 0. Where are we getting the 0 from? Okay, well the term is a constant term, it's 4. Are there any variables in this term? No. So if there's no variables, there can't be any exponents on the variables, okay? Now, this does not mean that this is 4 to the 0 power. It means that there's no exponents on any variables because there's no variables. So we would say this is 4 to the first power, but the degree of the term is 0. And here's another thing that's a little bit tricky. Again, going back to a past math class long ago or not last quarter, if you have a variable with 0 as an exponent, that is equal to the number 1. So 4 could also be written as 4x to the 0 power, which would be about like 4 times 1 or 4. Oh, well, there's a 0. Anyway, suffice it to say, if you have a constant term, a term with just a number, and you're talking about the degree of the term, that's algebraically, it's of degree 0. Okay? Now, how about this one? Negative 14y cubed plus 2y squared minus y minus 1. Okay, this is a polynomial. It has 4 terms. The first term is negative 14y cubed. Let's see. This is a variable term. Its coefficient is negative 14, and the degree of the term is 3. Okay? So the term is negative 14y cubed. It's a variable term because it contains at least one variable. Its coefficient is negative 14, and the degree of the term is 3. Let's see if I can write a little bit more legibly. Okay. Second term is 2y squared. This is a variable term. Its coefficient is 2, and the degree of the term is, let's see here, 2. Okay, because second degree. All right. Third term is negative y. This is a variable term. Its coefficient is what? What's the coefficient of negative y? Anybody know? No volunteers in our studio audience? It would be negative 1 because there's an implied 1 in front of the y, so negative y is like negative 1y. Okay? And let's see here. The degree of this term is 1. because again, there's an implied 1 exponent. And what's the fourth term? Oops. Fourth term is -1. This is a constant term. Its coefficient is -1. What's the degree? The degree of this term is what?
0.
Good job. 0. You passed. Excellent. Okay. Now, let's see here. Is this a monomial, a binomial, a trinomial, or none of the above? How many terms are there? Terms are separated by an addition sign. So how many terms are there?
1.
That'd be just one.
One term. So what kind of polynomial is it?
The mono.
Good. This is a monomial of degree what? Careful.
Do we add the 2 and the 3?
Bingo. Yes. The degree of a term is the sum of all the exponents on all the variables within the term. So excellent. This is a monomial of degree 5. What's its coefficient?
The 16?
16. Excellent. Okay. How about this problem? Let's see. 3y minus 5. What kind of polynomial is this?
Binomial.
No, how many terms are there?
Oh, wait, 1.
No.
There's 2, right? So it would be a binomial.
Right, because 3y is the first term, -5 is the second term. You count all the terms, not just the ones with variables, okay? So this would be a binomial. What's the coefficient of the first term?
3?
Okay, what's the degree of the first term?
1.
What's the degree of the second term?
0.
Excellent. All right. How about this? 2x cubed minus 5x squared plus 6x minus 3. Is this a monomial, binomial, trinomial, or none of the above?
None.
None of the above, right, because it's got 4 terms, so it's just a polynomial. Okay, what's the first term? What's the first term?
2x cubed.
Excellent. What's its coefficient?
2.
What's the degree of the term?
3.
Good. What's the second term?
The 5x squared.
What is it?
5x squared.
No, you're leaving something out.
-5x.
There you go, -5x squared. Excellent. Because remember, you got to think in terms of addition. Okay, so if it's a minus sign in front, that gets sucked into the term and makes it a negative. So what's the coefficient?
-5.
-5.
Okay, what's the degree of the term?
2.
Good. What's the third term?
6x.
What's its coefficient?
6.
What's the degree of the term?
1.
Good. What's the fourth term?
-3.
And its coefficient is also -3. What's the degree of the term?
0.
Good. All right, now, when you have a polynomial, like we have here, and you're analyzing it term by term, you do what we've got going on here. But what if we want to talk about the degree, excuse me, of the entire polynomial? The degree of the entire polynomial is the same as the degree of the highest powered term. So this is a polynomial of degree 3, okay? You don't add up all the exponents because they're on different terms, okay? The 3, the 2, and the implied 1 and the 0, those are all different terms. If you're finding, let's go back to this one. This is a single term, so the degree of the term would be 5. The degree of the monomial would also be 5. Okay, but here, the degree of this term is 3, this term is 2, this term is 1, this term is 0, but the degree of the entire polynomial is the same as the degree of the highest powered term. Okay, take a look at this. 14x squared y plus 3xy squared. Tell you what, let's put a cube on there. Let's make this 14x squared y cubed plus 3xy squared. This is a binomial. It has 2 terms. The first term is 14x squared y cubed. The coefficient of the first term is 14. The degree of the first term is 5, 2 plus 3. Okay, the second term is 3xy squared. The coefficient of the second term is 3. The degree of the second term is also 3 because don't forget there's an implied 1 if there's no exponent written. So we've got a 1 on the x plus 2 on the y is 3. Okay, so the first term is degree 5, the second term is degree 3. Now, what is the degree of the entire binomial? It's equal to the degree of the highest powered term, which is 5. So this is a binomial of degree 5, or you could say it's a 5th degree binomial. Okay, any questions on that? I want to talk about a game that some of you have probably played. Monopoly. How do you really say it? Nobody's played this game? Nobody plays Monopoly anymore? Okay, anyway, there's a game called Monopoly. And
I've played it.
Okay, good for you. I mean, I grew up on that. That's where I got all my math skills. So Monopoly is a combination of monopoly, so one mini. But nobody recognizes that as monopoly. What's that? Anyway, all right. Now, we're going to look at something kind of like that very first problem I did for a student. This says evaluate each expression. Okay, so evaluate the expression. So there's 2 S's in expression. We'll just kind of shove that in there. Evaluate the expression. Okay, we've got x squared minus x plus 7. And we're supposed to do part A where x is 6 and part B where x is -2. So when we're evaluating expression, we're going to put the value for the variable in place of the variable everywhere it appears in the expression. So let's take a look at this expression. This is a trinomial of degree 2 because the highest powered term is x squared, followed by a term that's 1 degree and a term that's 0 degree. Okay, so to evaluate the expression, we're going to put 6 in the place of x. So we're going to get 6, the quantity squared, minus 6 plus 7, which is 36 minus 6 plus 7, which is 30 plus 7, or 37. So when x equals 6, the value of the expression is 37. Any questions about that? All right, let's go back and evaluate the expression when x is negative 2. So negative 2, the quantity squared, minus negative 2 plus 7. Notice I'm putting parentheses around the substitution, around the number that's in place of the variable. This is x squared. So it's negative 2, the quantity squared. If I wrote it like this, that would give me the wrong answer. That would be 2 squared with a negative sign in front of it. So negative 2, the quantity squared, is going to be negative 2 times negative 2, which is what?
Four.
Good. Subtracting a negative becomes adding a positive. So plus 2 plus 7, 6 plus 7, 13. So the value of this expression when x is 6 is 37. We take the same expression but change the variable to negative 2, and its value is 13. Any questions about that? All right, let's take a look at another example. Let's say we've got x cubed minus 3x squared minus x plus 9, okay? And we want to evaluate the expression when x is 3 and when x is negative 3, okay? Clean that up a little bit. All right, so if x is 3, we get 3 cubed minus 3 times 3 squared minus 3 plus 9. 3 cubed is 27 minus 3 times 3 squared, which is 9, minus 3 plus 9. We get 27 minus 27 minus 3 plus 9. 27 minus 27 is 0. 0 minus 3 is negative 3, and negative 3 plus 9 is what? 6. So the value of this expression when x is 3 is 6. Okay. Let's take a look at the value of the expression when x is negative 3. So now we have negative 3 cubed minus 3 times negative 3 squared minus negative 3 plus 9. Negative 3, the quantity cubed, that's like negative 3 times negative 3 times negative 3. Well, if you're multiplying 3 negatives, an odd number of negatives, the answer is also going to be negative, isn't it? So this is negative 27 minus 3 times, but negative 3 times negative 3 is positive 9. Minus negative 3 is like plus positive 3 plus 9. So we've got negative 27 minus 27 plus 3 plus 9. Negative 27 minus another 27 would be what? Negative 54 plus 3 plus 9. Negative 54 plus 3 would be negative 51 plus 9, which is negative 42, I believe. Is that right? No one's going to affirm or deny? Okay, well, we'll just assume it's right then. Okay. Let's see, we're going to evaluate the following. So 6a squared b for a equals negative 2 and b equals 3. So now we've got a monomial expression with 2 variables in it. So we get 6 times negative 2, the quantity squared, times positive 3, which becomes 6 times let's see, negative times negative is positive. 4 times 3, 6 times 4 is 24. 24 times 3 is 72. So the value of this expression under these conditions is 72. Any questions about that? All right. Now the directions say, construct a table of solutions and then graph the equation. Okay, we're going to go back up here to this screen, and we're going to take the equation y equals x squared plus 1. Okay, now, whenever I'm graphing something brand new that I have no idea what it's going to look like, it's just a whole brand new thing, what I tend to do is I start with a table where I let x go from -3 to +3. Now, once I learn more about the type of graphs that I'm dealing with, I may change what I put in the table, but just at the very beginning, not knowing anything about it, I'm going to use x going from -3 to +3, okay? All right, now, if x is -3, then y equals -3, the quantity squared, because x is being squared, so -3 is being squared, plus 1. -3 times -3 is 9, and 9 plus 1 is 10. Is everybody okay with that? So when x is -3, y is 10. Okay? Let's take x being -2. So y equals -2 squared plus 1, which is 4 plus 1, or 5. Any questions there? If x is -1, y equals -1, the quantity squared plus 1, which is -1 times -1 is 1, and 1 plus 1 is 2. If someone asks you today, what did you learn in math? You can say, well, that 1 plus 1 is 2. Okay, excellent. How about if x is 0? Y equals 0 squared plus 1, which is 0 plus 1, which is 1. If x is 1, y equals 1 squared plus 1, which is 1 plus 1, which is 2. If x is 2, y equals 2 squared plus 1, which is 4 plus 1, which is 5. And let's see, I'll come over here. If x is 3, y equals 3 squared plus 1, which is 9 plus 1, which is 10. Notice that I'm getting some repeated y values here. That's because, for instance, -3, the quantity squared is 9, but +3, the quantity squared is 9. So plugging it in, I get the same value. Well, let's see what this graph looks like. -3, 10, I can't graph that with this grid, and I could switch grids and everything, but I don't want to go to all that trouble right now. So let's just graph the ones that we can, and that's these. If x is -2, y is 5. If x is -1, y is 2. If x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 5, and then 3, 10 is off the grid. Okay, so let's see if I can graph this thing. I've got this handy graphing tool here, and maybe this will help me and maybe it won't. So let's see here. Okay. All right. This is called a parabola, P-A-R-A-B-O, parabola, okay? We will be dealing with these graphs much later in the quarter, okay? But for right now, this is just a basic idea of what it looks like. So y equals x squared plus 1, there's its graph. Any questions about this particular graph? All right, I'm going to take a look at one more graph. So we'll do that now. Let's take a look at the graph of y equals x cubed minus 2. So again, I'm going to make a table going from -3 to +3. Okay. If x is -3, y equals -3, the quantity cubed minus 2, which is -27 minus 2, or -29. Well, I won't be plotting that point today. If x is -2, y equals -2, the quantity cubed minus 2, which is -8 minus 2, or -10. If x is -1, y equals -1, the quantity cubed minus 2. -1 times -1 times -1 is -1, and -1 minus 2 is -3. Finally, something I can graph. If x is 0, y equals 0 cubed minus 2, which is 0 minus 2, or -2. If x is 1, y equals 1 cubed minus 2, which is 1 minus 2, or -1. If x is 2, y equals 2 cubed minus 2, which is 8 minus 2, or 6. And finally, y equals 3 cubed minus 2, 27 minus 2, 25. Okay, let's see. I can graph, about all I can graph are those. -1, let's see, -1, -3 is there, 0, -2 is there, and 1, -1 is there. Okay, now let's see, -2, -10 is like way down here. So, and it's kind of hard based on just the small amount to see what this graph looks like. Okay, but I just want to do it on this grid, not go to the other screen. So it kind of looks like that. Anyway, that's it for section 5.4. So what I'm going to do is I'm going to stop the recording.